For chapter 3.3, we'll be dividing polynomials, and we're going to get into two theorems, the remainder theorem and the factor theorem. So we'll start with just dividing polynomials and how we divide them. So before we get into the two methods for dividing them, I just want to go over the division algorithm real quick. So when we're dividing two numbers, we can write it as a fraction. It would be the dividend divided by the divisor. We could rewrite that after we divide it as the quotient plus the remainder over the divisor. So let's do this example with numbers first. So let's do 37 divided by 5. So 37 divided by 5, what we would do is we would divide it like this. And say 5 goes into 37 7 times. You multiply 7 times 5, subtract, and we get 2. So this 7 is the quotient. The 37 is the dividend. The 5 is the divisor. And 2 is the remainder. So if we were to write this using the division algorithm, it would be, I'm going to write the whole thing. So we started with 37 over 5. It equals the quotient plus the remainder over the divisor, which hopefully we kind of remember this. This is actually how we would write it as a mixed number. 37 over 5 would be 7 and 2/5. Okay, so hopefully we remember this with numbers because we're going to be doing this same concept except with polynomials. So just rewriting the division algorithm to make it look a little bit more confusing, but with functions for polynomials. So we have the division algorithm right here. So f of x and d of x are polynomials. The degree of d of x is less than or equal to the degree of f of x, so we're just dividing them just like we just did. Then there's going to be some polynomials q and r. So q is for quotient, r is for remainder, such that we have this division algorithm. So once again, it's dividend over divisor equals quotient plus the remainder over the divisor. So the two ways that we're going to be dividing polynomials, long division and synthetic division. So we're going to start with long division first. The long division way is essentially the same way we just did it with 37 divided by 5. Okay, so for long division, we're going to start by dividing the highest degrees of the polynomials and proceed just like we did with dividing numbers. And we're going to continue doing this until the degree of the remainder is less than the degree of the divisor. When we do have to make sure that the polynomials are in standard form. So make sure both of them are in standard form when you're dividing it. And something to keep in mind, if the dividend or divisor actually is missing a term, then write the term in using a 0 as the coefficient. You don't have to do this for long division, but it's going to make it a little bit easier so you don't make any mistakes. And we're going to be writing each answer in the form of the division algorithm. So let's do this example. So let's divide x squared plus 10x plus 21 divided by x plus 3. So I'm going to set this up like this for long division. And what we do is we look at the highest degrees. So the highest degree of the dividend is x squared. The highest degree of the divisor is x. If you have to, on the side, just divide them. X squared over x is x. So what that means is that's going to be part of our quotient. I'm going to put it directly over the x term in the dividend just to make it organized. And then I'm going to take that and I'm going to multiply the x to the divisor. So x times x plus 3 is x squared plus 3x. And then we subtract it. So don't forget to put parentheses around the x squared plus 3x because we're subtracting both terms. And now we actually subtract them. So we get x squared minus x squared is 0. So those cancel, which is what should happen every time. And then 10x minus 3x is 7x. And then we're going to bring down this 21 plus 21. And then we're going to do that process all over again. So now we're going to think, how many times does x, what do we have to multiply x by to get to 7x? Or if you have to on the side, you just divide them. 7x divided by x, which is 7. So that's going to be plus 7 in the quotient. We're going to multiply that 7 times x plus 3. 7 times x plus 3 is 7x plus 21. We subtract. When we subtract this, 7x minus 7x is 0. 21 minus 21 is 0. We actually get a remainder of 0. So what this means, once we get into the factor theorem, we'll see this again. This means that x plus 3 was actually a factor of x squared plus 10x plus 21. So it goes in nice and evenly. So I'm going to write this using the division algorithm just because it's a little bit, I think it's a little bit cleaner and it helps us see exactly what we did. So that means that x squared plus 10x plus 21 divided by x plus 3, so dividend over divisor, equals the quotient plus the remainder over the divisor. So that's pretty silly, right? We're not going to write that 0 over x plus 3. So we're just going to write this as x squared plus 10x plus 21. We divided that by x plus 3, which equals x plus 7. So that would be our answer here. This whole thing just equals x plus 7, but written in the division algorithm would be that whole thing. So we actually knew that before without even doing long division. So I'm just going to do this on the side. So I'm just going to put, we knew that, answer, because if we start off with this, x squared plus 10x plus 21 divided by x plus 3, we can factor that numerator as x plus 7 times x plus 3 divided by x plus 3. The x plus 3's cancel and we're left with x plus 7. So that obviously won't always happen, but that's kind of a nice way to check our answer. So let's do a couple more here. So we have 4 minus 5x minus x squared plus 6x cubed divided by 3x minus 2. So first, when we're writing this out, we need to write the dividend in standard form. So we need to write it in decreasing order for the exponents. So 6x cubed minus x squared minus 5x plus 4 divided by 3x minus 2. Okay, so we're going to think, what do we have to multiply 3x by to get to 6x cubed? Or we can think of, or if you don't want to think of it that way, you just divide them. 6 divided by 3 is 2. X cubed divided by x is x squared. So I'm going to put that over this x squared, so 2x squared. And then we're going to multiply 2x squared by 3x minus 2. We get 6x cubed minus 4x squared. Okay, and then we're going to subtract these. So it's going to be negative x squared minus negative 4x squared. That's negative x squared plus 4x squared, which is 3x squared. So the x cubed terms canceled off, as they always will. We're going to bring down these other ones. And then we're just going to do it all again. So what do we have to multiply 3x by in the divisor to get to 3x squared? So that's the same thing as saying that's 3x squared divided by 3x, which is just x. So that's going to be plus x up here. We're going to multiply the x through and then subtract it. So x times 3x minus 2 is 3x squared minus 2x. The x squared terms cancel. Negative 5x minus negative 2x, we get negative 5x plus 2x, so negative 3x. Bring down the 4. And we can do this one more time. So it's going to be, what do we have to multiply 3x by to get to negative 3x? So negative 3x over 3x is negative 1. So that's going to be minus 1. Multiply that through. Negative 1 times 3x minus 2. It's negative 3x plus 2. Subtract. The x terms cancel. 4 minus 2 is 2. So the degree of 2, this remainder, is degree 0 because there's no variable there, which is less than the degree of the divisor. So we're done. Now we can just write this in the form of the division algorithm. So the original question was 6x cubed minus x squared minus 5x plus 4. We divided that by 3x minus 2. We said it's equal to the quotient, which was this, plus the remainder over the divisor. So this would be our answer using the division algorithm. Okay, so let's do maybe one more of these and then we'll do a different one. So let's set this one up. So 6x to the 4th plus 5x cubed plus 3x minus 5 divided by 3x squared minus 2x. So it's going to be, this is already in standard form. So what I'm going to do here is I'm going to recognize that we're missing an x squared term in the dividend. I'm going to put in a 0x squared. So technically it's not 100% necessary for long division, but it's definitely, I definitely recommend that you do it. We're dividing this by this. Okay, so for the first term here, first terms, 3x squared times what is going to give us 6x to the 4th. 6x to the 4th divided by 3x squared is 2x squared. So that's going to be plopped right here. Multiply that through the divisor, we get 6x to the 4th minus 4x cubed. The reason why we put that 0 term in there is because everything's going to line up now the way that it should. So the x to the 4th terms cancel. 5x cubed minus a negative 4x cubed, that's 5 plus 4, so 9x cubed. Bring down everything else and then do it again. So plus the 0x squared plus 3x minus 5. So what do we have to multiply 3x squared by to get to 9x cubed? So we divide them and we get 3x. So plus 3x. And multiply that through. 3x times the divisor gives us 9x cubed minus 6x squared. The x cubes cancel. 0 minus negative 6. 0 plus 6 is 6x squared. So you can see how the x squared terms lined up perfectly. We bring down the other ones, and it looks like we can do this only one more time. So what do we have to multiply 3x squared by to get to 6x squared? So we divide again, and we get a value of 2. So the last part of the coefficient, or the quotient rather, is going to be 2. Multiply that through and we get 6x squared minus 4x, subtract 3 minus negative 4, 7x. Bring down that 5, that's going to be part of the remainder. So we know we're done here because the degree of that remainder is a degree 1. The degree of the divisor was degree 2. So I'm going to write this using the division algorithm again. So it's going to be 6x to the 4th plus 5x cubed plus 3x minus 5. And it's going to be 3x divided by 3x squared minus 2x equals the quotient plus the remainder over the original divisor. So that is our result right here. Okay, so for this next one, what I'm actually going to do, I'm going to pause the video. I'm going to fill it out and do it. I'm not even going to explain it. I'll leave it to you guys if you want to go through and do it. I'll have the answer on here for a second, and then we'll move on to the next one. And here is the answer to that problem written using the division algorithm. So I'll leave it like this. You can pause it if you want to try it by yourself. But I'm going to move on to the next topic. So actually, I forgot there was another one after this one. So I'll do the same thing for this one. I'll just write the answer out in a second, and then I'll move on to the next topic afterwards. And here's the answer to that one. So once again, you can pause it, try it on your own if you want, but I'll move on to synthetic division. So that was long division. For synthetic division, it's going to look a lot different. It's going to be a little bit shorter. The key for this one is we cannot always use synthetic division. We can only use this if the divisor is in the form x minus c or x plus c, where the c is just a number here. So that means the divisor is a linear expression with a coefficient of 1 on the variable. And like I mentioned, this is typically a quicker method. And what we're going to be doing is we're only going to be using the coefficients of the polynomial. And we're going to be setting it up in a couple rows. So I'll kind of just go through and explain it in an example. And when we set up the coefficients of the dividend, we have to make sure that we write the coefficients in order from highest degree to smallest. And we need to use a 0 for a coefficient if it's missing a term. So we have to put a coefficient of 0 in if it's missing the term. Okay, and then for this little note that I put down here, when we're dividing by something in the form x minus c or x plus c, the remainder is always going to be a constant. So the remainder is just going to be a number. So let's see how we do it with just an example here. So we want to divide x cubed plus 4x squared minus 5x plus 5 by x minus 3. So first, we can see that this is in the form x minus c. So it's x plus or minus a number, so we can do this method. Our c value here is going to be 3. So it's x minus c, x minus 3, so c is equal to 3. So c is not negative 3, it's positive 3. This matters because we're going to start off by using that. We're going to take that 3, that value of c, and box it in like this. So this is our value of c. Next to that, we're going to write the coefficients of the dividend in the correct order. So the coefficients are going to be 1, 4, negative 5, and 5. And those are the coefficients of the dividend. And next, we're going to leave room for another row underneath it and draw a little line, which is kind of going to be like a little equals line, equals to line. Okay, so what we are going to do is we're going to use those coefficients and that c value to find the coefficients of our quotient. So what we do is first, we're always going to bring down that first coefficient and put it right here. What we're going to do is we're going to multiply that c value by this number down here that we dragged down, and we're going to put the result right here. So this is going to be times 3. 1 times 3 is 3. We're then going to add down. 4 plus 3 is 7. So I'll put add. And then we repeat that. So now we do c times 7. So 3 times 7 is 21. We put this right here. We add down. Negative 5 plus 21 is 16. And then again, 3 times 16 is 48. And we add down and get 53. So it's a lot of just multiplying, adding down, multiplying, adding down. So this last number right here is always going to be the remainder. So that's the remainder. These numbers right here represent the coefficients of the quotient starting 1 degree less than the dividend. So our dividend here was a cubic. It was x cubed. That means our quotient is going to be x squared. That's because we're dividing by something in the form x plus or minus a number. So we're dividing by an x. So it's going to be 1 degree less than. So let's see how this looks. So that means in division algorithm form, it's going to be we divided x cubed plus 4x squared minus 5x plus 5. We divided that by x minus 3. So our coefficients here, 1, 7, 16, it's going to be 1x squared plus 7x plus 16. So you can see how we just go right down with the degrees, degree 2, degree 1, degree 0 for the constant, plus the remainder over the original divisor. So probably didn't seem that short just because I had to explain every single step, but that's how you do it synthetic division. So let's do a couple more, do 2 more of these ones. So let's divide 5x to the 4th plus 6x plus 8 by x plus 2. So this is in the form x minus c. The c here is negative 2, so it's just the opposite of what you're looking at. So instead of, even though it says x plus 2, its c value is negative 2. So setting this up, we take the c value, box it in. We're going to write the coefficients of the dividend. It starts with the 4th degree. It's missing the 3rd and 2nd degree, so we need zeros in there for it. And then 6, and then 8. We're going to bring down that first one. So pretty much everything we did so far is just the setup. Now we're going to multiply, add, multiply, add, multiply, add. So negative 2 times 5 is negative 10. Add down, we get 0 plus negative 10, negative 10. Negative 2 times negative 10 is 20. Add down 0 plus 20, 20. Negative 2 times 20, negative 40. 6 plus negative 40, negative 34. Negative 2 times negative 34, 76. 8 plus 76 is, oops, just kidding. Negative 2 times negative 34 is 68. And then 8 plus 68 is 76. There we go. Once again, keep in mind that this is the remainder. Okay, and for our answer using the division algorithm, it's going to be, we just divided 5x to the 4th plus 6x plus 8 by x plus 2. That's going to equal the quotient. So our coefficients here, the 5, negative 10, 20, negative 34, they're the quotient's coefficients. We started with the dividend of degree 4. That means we're going to start our quotient with one less than that with degree 3. So it's going to be 5x cubed minus 10x squared plus 20x minus 34 plus the remainder of 76 over the original divisor. And that's going to be our answer. So let's do one more because they're pretty short. So let's divide x cubed minus 7x minus 6 by x minus 1. So there's a reason why I want to do this one still, even though maybe we probably get the idea of it. So the divisor is in the form x minus c. Our c is positive 1. So we're going to box that in. Coefficients of the dividend are 1. It's missing the x squared, so coefficient of 0. And then negative 7, negative 6. Bring down that first term. So multiply, add, multiply, add, multiply, add. 1 times 1 is 1. 0 plus 1 is 1. 1 times, oops, did I miss something? Nope, looks good. So 1, 0 plus the 1, 1, 1 times the 1, 1, negative 7 plus the 1, negative 6. And then 1 times the negative 6, we get negative 6. And then add down negative 6 plus negative 6, negative 12. So this is our remainder. Okay, so setting this up, we're going to get x cubed minus 7x minus 6. Divide that by x minus 1. We get the quotient, so it's going to be starting with an x squared. 1x squared plus 1x minus 6 plus that negative 12 over the divisor. Okay, so what I'm going to do, I'm actually going to add one more example in here, and I'll do it pretty quickly. I just want to add it because it'll get us into the theorem that we're about to do. So let's do this one right here. So let's write out the coefficients for synthetic division. But first, real quick, recognize that this is x minus c, and our c is negative 1. So we're going to box in that negative 1, and then we write out these coefficients, our 1, 1, 2, 3, and 1. Bring down the first one, multiply, add, multiply, add, multiply, add, multiply, add. So the reason I wanted to do this last example here is so we get a remainder of this 0. Just so we can see what it means once we set it up. So let's set up our answer. So it's going to be, in the division algorithm, it's going to be x to the 4th plus x cubed plus 2x squared plus 3x plus 1. We divided that by x plus 1. So our answer, our quotient is going to be degree 3, one less than the dividend again. So it's going to be 1x cubed plus 0x squared, so I'm not going to draw it, or I'm not going to write it, plus 2x plus 1. And that's going to be plus 0 over the divisor. So we do not have to write that, right? Anytime the remainder is 0, we don't need to write 0 over something, so I'm just going to erase it. And this is our answer. So we'll see for the second theorem, what this actually means is that this is a x plus 1 is a factor of that degree 4 polynomial, because we got a remainder of 0 and we divided it. Okay, so let's get to the two theorems. So for the first one here, let's do the remainder theorem. So the remainder theorem isn't really the bad one out of the two, the hard one. The other one is, the factor theorem is a little bit difficult. So the remainder theorem says that if a polynomial f of x is divided by x minus c, or x plus c, the remainder that we get is going to be f evaluated at that c. So this c right here, those are the same values. So let's do an example. So let's say we're given f of x is x cubed minus 4x squared plus 5x plus 3. And we want to use the remainder theorem to find f of 2. So what that means, using this theorem, is if f of x is divided by, so I'm almost repeating what the remainder theorem exactly says. If it's divided by x minus c, the remainder should be f of c. So if f of x is divided by x minus 2, the remainder is f of 2. Because that's what we're looking for, so that's why I did it that way. So what we're going to do is we're going to divide x cubed minus 4x squared plus 5x plus 3 by 2, by x minus 2, using synthetic division. So if we do that, that means that 2 is what gets boxed in. Now the coefficients of the dividend are 1, -4, 5, and 3. And we do exactly what we just did. And our answer is going to be the remainder. So bring down the 1, 2 times 1, 2, add down the column -2, 2 times -2, -4, add down the column 1, 2 times 1, 2, add down the column 5. So here is our remainder. So what that means is, based on the remainder theorem, f of 2 equals 5. So hopefully you're thinking to yourself, that's kind of silly. Why didn't we just evaluate f of 2? And you would kind of be correct. So let's check it. So let's evaluate f of 2 using the function. So plugging in a 2 everywhere, that's going to be 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. That should equal 5. So that's like a nice check for this, but the remainder theorem tells us a different way to evaluate a polynomial at a given x value. So let's do one more. So let's do, given f of x is x cubed minus 3x plus 2. Let's use the remainder theorem to find f of -4. Based on the remainder theorem, this says if f of x is divided by x minus -4, so that's x plus 4, that means the remainder is f of -4. So don't let the negatives be too confusing here. Okay, so what we're going to do is we're going to divide by x plus 4, which means our c value is -4. So all you have to do for this is take the value and use that as your c value, and then do synthetic division. So the coefficients are 1, there's no x squared term, so 0, and then -3 and 2. So bring down the 1, multiply, add, multiply, add, multiply, add. So this right here is our remainder. So this tells us our answer is f of 4 equals -50. Thanks to the remainder theorem. Once again, we can check our answer. We can evaluate f of -4 by plugging in a -4. -4 cubed minus 3 times -4 plus 2. Evaluate all that, we should get -50. Okay, so that's the remainder theorem. It helps us, in this case so far, it helped us evaluate a function at a given value for x. So the next thing is the factor theorem. So we'll see how this is going to get a little bit more confusing now. So the factor theorem says that if f of x is a polynomial, then the two things hold. They're essentially the same thing in the opposite order. If f of c equals 0, so if we evaluate the function at a certain number c, and it equals 0, that means x minus c is a factor. And then going the other way, if x minus c is a factor, then that means f of c equals 0. So let's see an example here. So let's consider f of x equals x squared plus 10x plus 21. This is going to have two values, so two x-intercepts. So f of -3 is going to be 0, and so is f of -7. So we could set it equal to 0, factor it, set them both equal to 0. So I'm just going to work with the -3 root. So I'm going to say f of -3 is 0. Based on the factor theorem, this means that x plus 3 is a factor. I'll actually bring in the negative 7 also. If we evaluate f of negative 7, this also equals 0, which means x plus 7 is a factor. We know this is true because we know that x squared plus 10x plus 21 gets factored into x plus 3 times x plus 7. Okay, so that's all that means for that direction. I'm going to go the other direction now, which is going to look pretty redundant. It's going to be the same thing, but in the reverse order. So I'm going to say, since x squared plus 10x plus 21 equals x plus 3 times x plus 7, that is going to tell us that f of negative 3 equals 0 and f of negative 7 equals 0. So when it's factored like this, you can tell that that's true, because if we plug in negative 3 into x, it's going to be negative 3 plus 3, which is 0. So 0 times whatever the other term will be will give us 0. Same thing if we plug in negative 7. So it probably seems pretty silly writing down both things here, but technically that's what the factor theorem tells us. So for the factor theorem, the whole point of it, not the whole point, but the majority of the point, what it's going to do, it's going to help us find roots, which are the x-intercepts, if we're given one of the roots. So we're going to be given a function. We're going to be told what one of the x-intercepts are. We're going to use the factor theorem to help us find the other roots, the other x-intercepts, by using synthetic division. So once we use synthetic division, the quotient is going to be the other factor. So we're going to set that equal to 0 to find the other roots. Okay, so let's do an example here. So let's solve x cubed plus 5x squared minus 2x minus 24 equals 0, given that 2 is a 0 of that function. So based on the factor theorem here, we are told that 2 is a 0. So that means f of 2 equals 0. Based on the factor theorem, this means that x minus 2 is a factor of f of x. And this means that function f of x can be written as x minus 2 times something else, which I'm going to call q of x. And we can find that q of x by dividing x minus 2 on both sides. So we can find it by dividing the x minus 2. So that means q of x is going to equal the function divided by that factor x minus 2. Once we do that, that's going to tell us what q of x is. Then we're going to set q of x equal to 0 and solve for x. Okay, so kind of a lot going on, but it's not too bad. So let's do this example. So what we're trying to do in the beginning here, before we even do the problem, we're trying to find this. We're trying to find x cubed plus 5x squared minus 2x minus 24 equals 0, right? So what we're going to do is we factored it halfway. Based on the factor theorem, we know that we can factor it as x minus 2 times something else will be the same exact thing. So we can find that something else by using synthetic division. So synthetic division here, we plug in our c value of 2. We put our coefficients of the dividend, which is just the function 1, 5, negative 2, negative 24. and then we do exactly what we were just doing. We know the remainder is going to be 0 already, which it always will be for these questions. 2 times 1 is 2, add down 7. 2 times 7, 14, add down 12. 2 times 12, 24. Add down, we get 0. So that's the remainder. So that means our quotient is going to be 1x squared plus 7x plus 12. So all we really need to worry about is that quotient set equal to 0. So now we're just solving this new factored version. So what I'm going to do is I'm going to factor that quadratic, x squared plus 7x plus 12. And I'm only doing this because it can be factored. Usually it won't always be able to. It can factor to x plus 4 times x plus 3. I'm going to set all of these factors equal to 0 now based on the zero product property. So solve all of these linear equations. We get x equals 2, x equals -4, and x equals -3. So we already knew the x equals 2 answer. I just like to write it down also as we go. But these are our answers. These are our x-intercepts here. So I'm going to write this as a set. -4, -3, 2. So we could check these if we really wanted to by plugging them back in the original and making sure they worked. But I'm not going to do that. Okay, so let's do another one. So I'll just do this one. I'll walk through this one, and then for the last one on the next page, I'll just write down, I'll pause the video, I'll write down the answer, and then you can check it if you want. So we're trying to solve this polynomial set equal to 0. We're told that -1 is a 0. So I'm going to write this one a little bit less than last time. So based on the factor theorem, f of -1 equals 0 means that x plus 1 is a factor of f of x. So what that means is that when we're trying to solve 15x cubed plus 14x squared minus 3x minus 2 equals 0, that means we can factor it as x plus 1 times something equals 0, and we can find that other something by synthetic division. So we're going to use that -1, that's our c value. We're going to write down the coefficients of the dividend, 15, 14, -3, -2. Bring down that 15, multiply, add, multiply, add, multiply, add. Make sure that you always get a remainder of 0 for these questions based on the remainder theorem. So those are the coefficients of our quotient. So that's going to be 15x squared minus x minus 2. So both of these examples had a quadratic as our quotient because they were originally degree 3. So now here what I'm going to do, this does not factor unfortunately. So what I'm going to do is set this equal to 0. We get x equals -1, which we already knew because it was told to us. For this quadratic equal to 0, we're actually going to need the quadratic formula. So setting this up, I'll do it over here. Quadratic formula is going to be x equals -b plus or minus square root b squared minus 4ac all over 2 times a. So plugging everything in here, we're going to get negative b, so b is -1, so -1 is +1. b squared, so that's -1 squared, which is 1, minus 4 times a, which is 15, times c, which is -2, all over 2 times a, which is 2 times 15. So if we simplify this, we're going to end up getting, x equals 1 plus or minus 11. We actually get a perfect square for underneath that radicand over 30. So what that means is we're going to do 1 plus 11 divided by 30 and 1 minus 11 over 30. This is going to give us negative 1/3 if we simplify it, and 2/5. So 1 minus 11 is negative 10. Negative 10 over 30 is negative 1/3. 1 plus 11 is 12. 12 divided by 30 ends up being 2/5. So that's actually going to be our solution set. I'll write these answers again right here, though. Okay, so our answers are those three answers. We get negative 1, negative 1/3, and 2/5. And just remember that when the amount of answers that we can get for a polynomial, for the amount of x-intercepts, is at most going to be the number of the highest degree of the polynomial. So this was a degree 3 polynomial. So we're going to have at most 3 answers, and we did have 3 answers here. Okay, so for this last one, what I'm going to do is I'm just going to, I'll write it out, fill it out, I'll pause the video, and then when I unpause it, it'll be filled out for you guys, and then you can check your answer if you want. And here's the final answer here. So if f of 2 equals 0, which was told to us, that means that x minus 2 is a factor of f of x. So I set it up over here on the left once again. I used synthetic division to find the quotient, which is the other factor, and then I set that quotient equal to 0 to find the other zeros. I had used the quadratic formula again, so I got these answers here. So I got the answers of negative 1/2, 1, and 2, and the 2 was told to us in the question. So we got pretty nice rational numbers for our quadratic formula. Obviously that won't always happen. We could get an irrational number where there's still a square root in there, which is fine. These ones we just got nice numbers. So if you want to, hopefully you paused the video and tried that one on your own, and you hopefully got it right. So that is it for section 3.3.